This podcast is brought to you by the School of Advanced Study, University of London.
Good morning everyone and welcome to the Institute of Philosophy, the Centre for the Study of the Senses. I'm Barry Smith, I'm the Director of the Institute of Philosophy, but I'm also the AHRC's Leadership Fellow for the Science and Culture theme. And it's because of the Science and Culture theme that we are able to be here for the launch of this brand new project, Rethinking the Senses, which is directed by colleagues from the Centre for the Study of the Senses, along with colleagues from Glasgow, Oxford and Warwick. Now the Science and Culture theme is a new initiative by the AHRC, and I think a very timely one. Timely. It was, my colleague Colin Blakemore will be here in a minute to tell you a little bit about the project, but I will just say something about the theme under whose auspices this project runs. So it's a very good moment, I think, in the humanities to find ways in which some of the work that goes on in the humanities can make common cause with many branches of inquiry in the sciences. And this kind of interdisciplinary work is, I think, new. There's always been a sense of interdisciplinary discussion within the sciences, within neighbouring sciences of neuroscience and psychology, and also within the humanities between history and literature and classics and so on. Classics itself being multidisciplinary, to do with language and history and philosophy. And yet, there's a moment now which I think is becoming ever more important, where many of the issues that people in the humanities want to address about the nature of the mind, about our nature as social beings, about our connections with one another, about the way in which the past might inform us about the future, many of these issues spanning the humanities and the arts are beginning to be partly addressed or informed at least by work going on in the sciences, and in particular from the discipline I belong to, from the sciences of psychology and neuroscience. And I think it's also a good time to see that many of the scientists that we've been working with have also wanted to have their work informed or located within a picture that talks about us as human beings living in the social world, organizing our lives according to cultures and traditions and history that has preceded. And there's a way to sometimes set a context or set a surround and a background to the questions that science is raising. Now, it's because we have seen lots of examples, beautiful examples, of very natural working and collaboration between scientists and researchers in the humanities that the AHRC thought it was time to create rather larger grants. And these large grants of up to £2 million were created with a very high expectation that the projects that were funded under the Science and Culture theme would have to show bi-directionality. There really would have to be a way in which the work in the science was contributing to and developing what was going on in the humanities, and the humanities was making a substantial contribution to the fields of science too. So it had to be bi-directional, and the aim was that it had to be transformational. It had to be possible for each side to transform the workings of methods or the research questions or the inquiry and knowledge that was produced on either side of their disciplinary divides. Now, some of you have heard me say this before, but I think you can only do good interdisciplinary work when you start from a strong disciplinary base. Good fences make good neighbours. You need people to know their subject very well and to be able to take an interest and have an ear open to understand what's going on in the other field. But to contribute to it is also to recognise the differences and the way in which this is not how you pursue the same topic and not the same approach that you're using. But you want people to come from a strong disciplinary base, because I think whichever discipline you're in, if you're turning to colleagues elsewhere, they have to be good guides to you. They have to tell you what you don't know. They have to be your eyes and ears. They have to let you see and understand what's going on in the other field of inquiry and understand its methods and tell you which questions matter and which ones don't. Now the bar was set so high to ask people to meet these conditions, to be reciprocal in their working, to be transformational, that there were very few candidates, in fact 8 finalists for the large grants. And after we had interviewed everyone, we were very clear that there were 3 projects that we thought were outstanding and that met these conditions. Now, notwithstanding the awarding of a grant to 3 different projects, when we prepared people for their final interviews, we prepared them for their final submission, we had talks by a number of different researchers who had done this sort of collaborative work. We had Joël Proust from Paris, and we had Andreas Ropstoff from Denmark. And at that meeting, funded by the AHRC, Andreas said, yes, you can have interdisciplinary working, yes, you can have bidirectionality, but no, he thought it was impossible to be transformative. He thought this was too high a bar. The AHRC were not happy to have this said at a meeting that was preparing people to make this claim. However, the very sensible folk who we interviewed for these awards, I think gave the right answer. So when the question is, will this work be transformational? The answer is yes, but it'll take time. And it'll take time because it requires a lot of dedicated discussion of just what is being contributed by each of the disciplines and whether or not you are making progress. There's a kind of bad interdisciplinarity. I think we see it with a lot of retired Nobel physicists who live in places to the east of here, who might think, oh yes, I work on something that's very difficult and complicated, and I've realized that physical matter is very complicated, and you've realized that consciousness is very complicated, so maybe it's the same complication. And here you've reduced 2 really hard problems to one really rather indeterminate problem. That's not what we were looking for. We're looking to see in specific detail if the work that's done on the senses by philosophers of perception, which has been going on for 2,500 years, and until very recently had certain assumptions about the way the senses worked, we are now in a position, I think, to see how what happens in neuroscience and what happens in psychology itself, having recently changed, is transforming the landscape and making us think differently about the number of senses we have and about the way the senses interact. And it was this idea of philosophers and psychologists, neuroscientists working together, which the Center for the Study of the Senses was created to foster. And I'm very glad to say that when the hard work was done and the project was submitted, and colleagues from here in London contributed, along with many partners in Europe and many partners around the UK. They were utterly convincing that we had now one of the projects that was going to meet these conditions. But as usual, when you do interdisciplinary work, as Andreas Ropstoff says, there are 4 stages. The 4 stages are communication, confusion, conflict, and then collaboration. Now I think there are certain interdisciplinary events, maybe yesterday's one, where you see us having got to at least stage 3. But I'm very glad to say that this project and its partners have got to stage 4, and there's genuine collaboration taking place. So now I'm going to leave you in the hands of the principal investigator of the large grant, Colin Blakemore, to tell you more about the project.
Thanks very much. What I'm hoping is that we might be able to get some sound amplification. I don't know whether any. Who knows whether these, for instance, the.
No, they're disabled, unfortunately, permanently. Yeah.
So no chance of any sound.
And no chance.
We'll talk on whether introduction to multisensory integration is a considerable disadvantage. All right, well, I won't do it. Let me tell you very briefly what we're hoping to do against the backdrop of what Barry said about the the difficulty of the criteria for these awards. I mean, as you said, there's no doubt that interdisciplinarity, that the interactions across the boundaries of the humanities are happening, but defining what's good about it and how to do it is not that easy. I think we had a huge advantage for several reasons in the project that we presented. First, that a lot of the spade work had already been done here in the Centre for the Study of the Senses in building relationships and collaborations, active collaborations between philosophers and neuroscientists and psychologists. So the contacts and the links to develop a convincing application were already there. Secondly, there's the theme, the nature of the theme itself. What we propose to look at is the nature of perception of our sensory experiences, which is, of course, a topic that has entertained and puzzled philosophers for 2,000 years or more and scientists for at least 500, with quite a lot of interaction between them along the way. And I'm fond of pointing out that John Locke was a laboratory assistant to Thomas Willis in the 17th century in Oxford, one of the founders of modern neuroscience, a person now recognised as a philosopher on that side of the disciplinary boundary, working in a dissecting room, trying to understand how the structure of the brain worked alongside a physician. So there are lots of precedents for the interaction in the study of the senses. So what we're proposing, and the title of our project is Rethinking the Senses, and this is a quote from the introduction to our application, is to study the senses as the basis of our subjective experiences, and pointing out that that is a central concern for the whole of the arts and humanities, we think extending to anthropology, to the social sciences, philosophy, history, culture, literature. It all is dependent on how we understand the world around us, other people, and ourselves through our sensory experiences. Just to use a bit of poetic license to point out how deeply embedded that question of how we see the world and ourselves is to culture. Just a little quote from a poem by Emily Dickinson, which in a few lines refers to 4 different references to an experience. A slant of light on a winter afternoon, which is like the weight of cathedral tunes, of bells, generating a hurt without a scar. So that metaphorical reference to the other senses must mean something. And what it means is that our sensory experiences so often depend on the relationship between our senses and interactions between our senses. This is a lovely comment made by one of our collaborators in Paris, Vincent Hayward. At the end of a letter of support for this application, he just slipped in a thought, and it's worth just reading through it. So it's an anecdote about a baker who came to see him, who had been terribly worried all his life by the way in which the dough that he started with became lighter as the yeast worked and it expanded. Of course, that was a very direct, real-life demonstration of a very compelling illusion, the size-weight illusion. We know he works on many ways in which what we see influences what we feel, what we touch, our impressions from the sense of touch. And as he says, while the baker went away, having gone to a demonstration, a public demonstration that Vincent was involved in after a conversation, went away at peace with himself, but still Vincent wasn't, because he couldn't really offer an explanation about those kinds of interactions in the brain, nor indeed about the relevance, significance, biological, adaptive value, or whatever of such interactions. So one of the questions we want to ask is, can we generate some kind of taxonomy of the way in which the senses interact with each other that will cast light on the value or otherwise of the different sorts of interaction? Do they fall into categories? If they do, is there a correspondence between those categories and the way in which the brain handles those interactions? And what about the funny ones that don't seem to make sense? Are they just anomalies in brain organisation, or is there more to it than that? So the team is working together on this is scattered across the UK, but with collaborators around the world. Fiona McPherson from Glasgow, philosophy from Glasgow, Matt Nudds from Warwick, who's the chair of the philosophy department there, Charles Spence, who's a psychologist, neuroscientist in the audience, from Oxford, who's a leading figure in the science of multisensory interaction, and then the Centre for the Study of the Senses here in London, with Ophelia de Roy and myself as applicants, and with the eminence grise figure of Barry looking over us. And as I said, a lot of what we have been able to develop has come through the connections that the senses have already developed. Some of you will certainly know about the incredible technical advances in neuroscience during the last 100 years or so, and which have undeniable power to define how the brain is actually handling things. I mean, the gulf between understanding that a bit of a brain is active, or even how it's active, and the experiences that are correlated with that activity is a gulf that shouldn't be underestimated. But nevertheless, we have a lot more knowledge about the brain and how it handles sensory information than we had in the past. And I'm talking about such things as the introduction in the early part of the 20th century of methods for recording activity from individual nerve fibers or nerve cells in the brain. These are some of Edgar Adrian's very earliest recordings with a capillary electrometer showing nerve impulses recorded from a sensory nerve, through to more sophisticated applications. This is just a picture very well known to neurophysiologists from the work of Hubel and Wiesel, who were the first to describe the properties of cells in visual parts of the brain responding selectively to certain shapes or features in the visual field. The contribution of neuropsychology. This is a summary of the different sorts of symptoms that are produced by damage in different parts of the extended visual cortex, subtle defects in the ability to recognize objects or features of those objects, such as movement or color or form, resulting from damage in different parts of the brain. Psychophysical methodology, in which people are simply asked to make judgments about when something has happened, or whether two things belong together, or whether they remember particular conjunctions and so on. That makes, and we'll have a laboratory here in Saint House for doing exactly that kind of work, as well as some non-invasive recording techniques, fMRI and other neuroimaging techniques, somewhat exaggerated, I think, in the popular media as to exactly what they show about the brain, but nevertheless enormously exciting, with wonderful pictures of blobs of activity in the brain, at least localizing where things are going on. And other applications, this is a particular technique called tractography or diffusion tensor imaging, in which MRI is used to show the direction of projection of tracts of nerve fibers in the brain, which, when combined with other techniques, allows one to make inferences about what's connected to what. And finally, a classic example from MRI of activity, in this case, work done in Queen Square on regions specifically active during the recollection of spatial navigation tasks, spatial memory. Now here's where sound would have been very nice, but you all know this. I was going to demonstrate the McGurk effect, in which I'm sure most, if not all of you, know that observing lip movements literally changes, if those lip movements are synchronized to sounds, to phonemes that you're hearing, can literally change what you hear. And it's undeniable that what you hear is different when you're looking at the lips compared with when you're not looking at it. Or looking at other lips or other movements, which raises really deep questions about the individuation of the senses and what we mean by a particular distinct Aristotelian sensory experience. And one of the issues we're interested in is why and how our visual experience is undeniably and categorically different. Whatever its form, whether it's movement in the field or colour or shape or distance, that kind of experience is undeniably distinct and different and could never be confused with an auditory experience, hearing a sound, listening to a concert, whatever. Those categories of experience are just different in that they are sounds, things we are hearing rather than seeing. And yet here we see a really compelling example, and an apparently adaptive one, helping us to understand what people are saying by looking at their lips, which contravenes that rule, where what you hear is directly affected and modified by what you see. So that's perhaps an example of a positive cross-modal interaction, but there are, here he is barring away, but without saying watching. What can neurophysiology and neuroscience tell us about that? Well, this is from the work of Gemma Calvert and her colleagues with one of the first studies of exactly that phenomenon, showing, comparing brain areas that were activated when any sound and any visual experience were heard together coming from the same apparent place in space, as opposed to speech sounds. And when they look specifically at what part of the brain appeared to be activated, when there was conjunction in time and space between speech sounds, looking at someone's lips and listening to sounds, they found activity in superior temporal sulcus, or region of the cerebral cortex, which we now know is involved in multisensory interaction, and they also saw enhancement effects in both visual areas and higher levels auditory areas. Interestingly, when they looked at areas that were selectively enhanced, where people simply heard sounds that were related in space to visual events, not language, then the activation that they saw was quite different, and it was not even, the principal activity wasn't even cortical, it was in a structure called the superior colliculus in the midbrain, which is known to be involved in the control of eye movements and orienting movements towards things, salient things of interest, subconscious processing, suggesting that when a visual thing happens at the same time as an auditory thing, at the same position in space, that is judged by the brain to be more salient than either of them happening alone. It drives eye movements and body movements towards that point. It's quite different from the very specific interaction between lip movements and sounds. Not all interactions, as I said, between the sense, not all of these interesting interactions between senses are obviously adaptive in the way that those examples suggest, and one that we're especially interested in, and many other people too. It's a sort of hot topic in neuroscience and psychology, and increasingly philosophy too, is the phenomenon of synesthesia, in which people have extrasensory, unusual sensory experiences. And when I say people, probably 4 or 5% of the population have this condition, and resisting any temptation to call it a disease or a disorder. It doesn't seem to carry any disadvantages. Interestingly, it doesn't seem really to have significant advantages either. And it's very odd for those of us who don't have it. People with this condition get extra bits of sensory experience that ordinary people don't get. Colin's form is seeing either, as it were, in the mind's eye, that's how people describe it, or sometimes apparently projected out into space. Colours, distinct colours, nameable, highly reproducible colours in association with certain spoken words, typically time words, days of the week, months of the year, things like that. People often see shapes distributed out in space, corresponding to the days of the week or the months of the year. So here's an example of that. Here's a chap describing his apparent visual experiences projected out in front of him when he heard days of the week read off, and that was last week, and this is this week. And he has different colours for the days of last week and this week. They appear in front of him, they move with his head, not with his eyes. One interesting feature, and that's very common. One interesting feature of this particular person is that he'd been blind for 20 years. So he had no real visual experiences, but still had very strong and compelling visual experiences attached to the wrong thing, to hearing things. He also saw coloured lights when he touched braille, for instance, corresponding to the pattern of braille dots. As he said, like looking at little LEDs in the form of the braille cell when he put his finger on the braille cell. He'd been blind for 20 years. Well, in his brain, there's activity in a very distinct region when he was listening to time words that produced these colours, compared with listening to other words of similar frequency of occurrence in language, which didn't generate colours. But a differential study to highlight a region that was selectively active during this experience. And here's this region at the back of the head, heading down towards the temporal lobe, called visual area 4, which is active in you and me when we look specifically at coloured objects rather than non-coloured objects. So his brain, somehow from above, turns on the very region which is active in we see colours when he's seeing these odd colours, but he's blind, so he's got no effective input from the outside of this region, but there it is, still working away, giving these odd experiences. But why? I mean, what's the value of these extraneous bits of sensory experience, if there isn't a value in people with synesthesia, and can the study of them tell us something about normal cross-modal interactions? So finally, is there any urgency in this project? Well, certainly from an academic point of view, yes. I mean, it really is the time is right. And these are just a couple of independent quotes. The first from the website of the centre here in London. From the philosophical perspective, there is no underlying theory or conceptual framework in which to house the numerous findings of multimodal interaction. And from a pivotal paper in the Science of Multimodal Interaction by Barry Stein and his colleagues 2 or 3 years ago, semantic difficulties arise when the term multisensory integration is used to refer to different neural processes. So there's confusion and misunderstanding on both sides. Our plan is to put philosophers and neuroscientists together, working systematically through key classical topics such as the binding of sensory information, consciousness and awareness, top-down control and attentional mechanisms and so on, working systematically through them to see if we can come to some kind of coherence, particularly to settle on key questions which we can then address empirically. Philosophers involved in designing experiments which they will then conduct with scientists, and we see that as a sign of a very promising interaction in the future. So I think a development in this field which is significant. So I want to help to begin the process of training a new generation of young philosopher scientists, if you like, who have facility on both sides of that boundary. I think I'll stop there in the absence of sound. Little more I have to say. So this sets the context for the two speakers we've asked to talk to us today with their wealth of experience in this area of multisensory interaction. Thanks to them, thanks to you for coming.
Welcome again. It's a great pleasure to be part of the application and today to welcome our first speaker, who is a professor of neuroscience, Bea De Gelder. She's in Maastricht at the moment, and also our invitation was presence here is all the more relevant that she was one of the founders of the European Society for Philosophy and Psychology. And so not only is she a prominent figure in the multisensory perception field, but also been very keen to develop interactions with philosophers. So please welcome Beatrice.
Thanks very much. So, I need to speak up?
Yes.
Is this clear? Okay, thanks very much for the kind invitation, and more importantly, congratulations on you people who got this grant. It's a tall order, as you certainly know. It's absolutely, the time is right for this kind of work, and you're doing things that, you're going to be doing things that we don't really clearly understand, but will be clear at the end. I have this view of science and philosophy as we start with questions, and then almost well we change your old questions for new ones. So that's my attitude. Now, an immediate thought that came to my mind that sort of summarizes what's in the back of this talk is that the previous speaker talked about rethinking the senses, but something as equally needed for me is the urge to rethink the brain, because we need to rethink the brain if we, my sort of message would be we need to rethink or conceptual approach to the brain if we want to understand, if we want to begin to rethink the senses. Now, what do I mean by that? I have like an immediate answer, and I'm just going to say it at the beginning of the talk. So I think we have been focusing too much on the brain as an organ of representation, and that forces us to raise the issue about the links, the connections between the senses. So we have actually, to some extent, created a false problem of multisensory integration. For one view, it's the natural way of looking at a combination of the senses when you look at the brain as a system for representation, perception as representation. However, if you look at it differently, or in combination with that first view, the brain as a representation, you have a view which will try to develop, but in the background really, the brain as an organ of presence. And then we don't have so much a problem as we have the separate senses and how do we combine them. Then we have a problem as we have we have senses and just to use an expression that was used a second ago, which is a good one, then we have an issue of individuation of the senses. So on the one hand, when you see the brain as something that puts us in the presence of the world, then we have a problem of how do we individuate the senses, because somehow it's not obvious how we individuate them. On the contrary, when we take the standard view, like the brain represents reality, to hear then we have this partly false problem of how are the senses being combined. And I haven't done much work about multisensory integration the last years, although we have started lots of things now, and I will show some stuff at the end. But I've always been very uneasy with the way, it's none of my business, right? I do, but very uneasy with the way standard multisensory research presents the problem. It's not that I have like a quick solution, but there is something wrong in narrowing down the problem of multisensory integration as it is put, like you have vision, audition, and then you add vision to audition, and then you get all sorts of cute little signals in the brain that prove you that there is integration. I find that concept somehow, and that's not unfortunately, I'm afraid, my old philosopher's obsessions, I just don't find that intuitively the right way of addressing the issue. Now I'm not talking about a lot of things, but that's in the back of my mind. What I would like to do is rethink the senses, but including the primary task of rethinking the brain. That sounded a bit grandiose, and I'm going back down now. Okay, good. Let's make a start with that. This talk is mainly going to be about body representation. And this is going to be too long if I give all the personal history. At one point, let me give you one anecdote. No anecdote, sorry. People in emotion, I was never going to work on emotion as a philosopher, you stay away from such topics. You remember the quote from Hilary Putnam, he says, we need 300 more years of empiricism before we can tackle those large issues like that. But anyway, having landed in that area is actually by working on audiovisual integration of speech and McGurk effect-like stuff 15 years ago. I said, well, that phenomenon maybe also obtains for the combination of facial expressions and prosody in speech. And I didn't see any reason why that same kind of issues about merging what you hear and what you see concerning prosody and emotional information would not also be a real serious issue and not that kind of derived. So, but that sort of got me to say, well, we certainly convey affective information by something else than just faces. And voices. We convey it to the whole body by the whole body expression. Face being part of it. And that launched a kind of research on body expressions, which I will mainly talk about, and I will certainly end with some stuff on voices and bodies also in the end. of course, I mean, it's obvious that all of us, we constantly understand, react, deal with, interact with bodily expressions. I mean, Western painting would be nowhere if we're not spontaneously standing in front of a painting like that. We would get it, whatever getting it means. So let's see. This, of course, there's some emotion involved here, but not emotion in like there's of course endless literature on emotions. But what motivates us to stay in that area is that we want to develop an approach that's consistent with the evolutionary rationale for emotion. And emotion is like not feelings, it's not this Cartesian phase as a window of the inner thoughts, the mind, etc., etc. But emotions, evolutionary speaking, are like tendencies people have to act when they get a signal. So that's it's not like a mentalist theory. And of course, then you find evidence in phylogenetically all the structures of the brain, and a good strategy for achieving that goal, if that's your view on what emotions or what effective information are, is of course to look at body expression. So that was the statements. Go a bit fast. The very first, so nobody has actually used facial whole body expression of emotion in the literature when we did the first studies like by now 10 years ago. And in the beginning we were sort of happy to find that actually there was some markers in the brain for this type of perception. And we found that with the N170, which in the literature qualifies as the unique beginning of face-specific processing, you find that same N170 when you use faces instead of bodies. So that was very straightforward. So sort of the initial relief, we are actually studying something that has some reality there. Second, similarly, also by now 10 years ago, we found that indeed using brain imaging, we could find markers that were specifically associated with emotional expressions of the body. And we blur the faces most of the time, but you can see that the two brain areas that still, after all those years, count as the hallmark of emotional face processing, namely fusiform gyrus and amygdala, you find activations there when you show the people body expressions. So that was just something to be. I'm just throwing this in now because it's work in progress actually. You may all know the system Paul Ekman developed, the facial expression system, the FACS system. We have in our continuing approach for like sort of a non-Cartesian externalist approach to emotional body expressions, we do measure muscle groups also with electrodes on the different muscles. And one goal of that approach is to find the equivalent for the body that you have with the facial action coding system, and find like sort of a signature of bodily expressions of emotion measured at the level of the muscles. I mean, that may interest some people. Now, so here comes the beginning of the troubles. It's fine to, it's always fine to find like the area in the brain that processes bodies, like people have found the area in the brain that processes faces, except, as Jerry Fodor would say, the brain doesn't work that way. So what we find here is from the first full study of body expressions, and you see that rather than having the famous, or depending on your view, the infamous body and face areas, we do find already at the beginning and ever since that when people watch a fear expression, a whole body fear expression, a face blur, of course, then you have a set of areas that are active, and this set of areas, you cannot narrow this down to that body, that area in the brain does bodies, that area does face. That's just a very misleading, I feel a very misleading view of how the brain works. So I'm just going to give you an idea of these areas. They are color-coded as they were in the original paper, because we still struggle with all of them actually. First, you have like areas that are typically involved in the subcortical areas, typically involved in rapid detection. There's like you walk in the street, you see an angry person passing on the side, and you will detect it somehow. You will pay attention to it. So that's the early rapid detection, which does require some involvement, which does mobilize subcortical structures. Then, of course, you have the much familiar visual processing. That's the more standard stuff. You have the emotional processing, you have the representation of the action of the person, and that's where the mirror people have come in. But that's just one part of the story. That's just one subset of the brain activity associated with seeing an angry or fearful body expression or something. And then you have the motor response, and that's very important because that's as we defined at the beginning. Emotions are actually there to make you do something. So those 4-5 sets of areas do remain absolutely important. Now, of course, the question in the back of our mind for the very end of my talk is, given that you have this kind of complex representation of how an emotional body activates your brain, then the question that will happen, that we will raise at the end is just how and where, if that body expression is accompanied by some growling, by some crying, by some shouting, just where is that represented? I cannot just pin down one of those areas to say, oh, that's where the multisensory integration occurs. So that's just good. Just to give you a little bit of background on the kind of work, in the beginning we used still images. People say they are not very realistic. In fact, they are more realistic than you think because they do activate motor and motion perception areas. But we work with some videos. I'm not going to show them because that stuff never works. But we used video clips, and from the beginning we wanted our approach to be quite really naturalistic, let's say. Namely, we used video clips of a person opening a door, which can happen in everyday life, and the person opened the door and said, hey, you were there, or good, you were there, or angry. I mean, it's non-verbal, but different ways of facing you when somebody opens the door. So that was that kind of situation. The reason I'm bringing this up is because already from the beginning we wanted to address one specific question, which is related to my issue about representation or presence. How do you represent this kind of? How do you present the action of somebody getting close to you and being angry at you or something? Do you first code the body? And let's say what the standard view of the field is, you first code the body. When it's a moving body, you have the so-called body area, and then that body area, the activity and body area, that body area is modulated by the valence of the stimulus. And that's the standard. You see a body, it hits the area in the brain that does bodies, and then depending on the emotion, it's modulated or not modulated by that. So that does not work very well because, as I said, we find a whole bunch of areas. The image, the video in this case, is decomposed in a whole bunch of properties that address different areas in the brain that in combination gets you this response. Now, one issue that's accompanying all the studies more and more, as I will show, and I spend more time on some than other, is that a lot of this happens like not the way we picture a subject in a lab staring at the screen and answering questions, but a lot of this happens like, let's say, in the periphery, where we do something and we are involved in some task, something happens on the street, somebody comes, or somebody talks to somebody and suddenly shows an angry body expression. So it's not like our focal attention. We are not, our brain is not sitting there saying, what would be the expression this person is going to show? No, there's an online processing of that. And to mimic that kind of situation, we very often use tasks where the person's attention is occupied by something else. So that we can really tap into those activities in the brain that spontaneously, automatically, and non-consciously, in various senses of non-conscious, can process that information. And here there's one example. Here we were comparing, this is an fMRI study, and I'm just showing it as an example because the stimuli were always the same, namely video clips with colored dots on them. But in one condition, the subject was actually asked to report at the end of each video clip whether the dots had the same or different color, and they were like 40 milliseconds dots. This was a pretty hard task. So the subject was fully involved in the task, versus in the other condition, had to name the emotion. Now, what we wanted to know is to what extent brain areas what brain areas are related to or recognizing explicitly the emotion versus what brain areas are related to noticing it and possibly reacting to it. Because I may be talking to you, and you may all of a sudden, you or somebody next to you may shout me a fist. I probably can go on talking for a couple of milliseconds, but my brain will already prepare be in a situation preparing to counter your aggressive action or your friendly action. And we did in this study, we were clearly able to pull apart the brain areas that are like involved in consciously representing and naming the emotion versus the ones that were involved in automatically reacting to the emotion. And again, of course, keep in mind the issue, if these video clips were accompanied by like sounds, in what system, which of these two systems would multisensory integration of the information take place, and how maybe in different ways. Okay, so we can find brain areas that are not influenced by the task the subject is performing, by the task the subject is involved in. And interestingly, these are the areas like periaqueductal gray, and to a lesser extent amygdala, that are known from the animal literature as being involved in reflexive. When you stimulate, for example, when you stimulate cells in periaqueductal gray, the animal will show a defense reaction. So you can show that in human fMRI, provided you make sure that your subject's attention is occupied by something else than recognizing the stimulus. So the brain will still automatically put itself in a state of readiness to react to the emotion independently of naming it or not naming it. So that's sort of an important issue for consciousness. Good. So as I said, one motivation for this kinds of studies, and I'm going to finish with this kind of studies, one motivation was to pull apart the structures in the brain that perceive and react to the emotion versus the ones that are like recognizing the stimulus. And there is this literature which is getting a little bit out of date now, but still comes up concerning mirror neurons and there is concerning the role of mirror neurons in perceiving the actions of others. And our view on this, resulting from a bunch of studies, is that it is not, that there is one view in the literature holds that first you recognize the action and then the emotion, and that's why mirror neurons have been argued to be the basis of social understanding, etc., etc. Our view is the other way around. I mean, you first activate the circuit in the brain that reacts to the emotion, and that does not depend on have other studies showing. So that's just motor resonance and emotional contagion have been confounded in the literature of the last 6 years, and that's just not a good idea. Okay, so this slide now summarizes a little bit, tries to summarize where we stood 5 years ago in the Nature Neuroscience Review paper, which by now is 6 years ago, and it already pushes us a bit towards this view I have anecdotically illustrated, namely that in the brain, that the circuitry in the brain to deal on everyday basis with interactions that are and communications through bodily language, we at least need to distinguish like a reflex-like preparation. Somebody hits somebody, comes close and wants to hit you, you immediately react whatever you're doing or saying, in an awareness, in between awareness system of our body and in the more standard perceptual system. To figure out how we do it for time. Because if you let me do it, you'll stop. Okay, so a little bit on the same tone, maybe I should skip that. I've told you there's this different circuits and different areas, and one way, of course, to sort of understand that is to use TMS, which is transcranial stimulation, where you can isolate one area, block one area, and see what the consequence is for other areas. But I think I'm going to skip this part. Anyway, the take-home message from that TMS study, which was neuroscience last year, I think, is that in terms of the areas that we stimulated different areas, I can go on back if you want to see that. So that we had still images, but interrupted by with slight differences in posture. Okay? And the subject's task was simply to say, was that the same or different than the previous stimulus? And the subjects were supposed to notice tiny differences in posture. We balanced this nicely to actually nice. We controlled this by having animal still frames taken from animal studies, snakes for the fear, for the threatening bodies, and nice small fish for the moving ones. And we found that the areas that are important here for influencing your recognition performance in this task was not a mirror neuron, that mirror neuron, the main mirror neuron area there was not the body area, but was posterior, was STS, that was superior results. But that's a long follow-up on that. The reason why this one fits in the story here is that if you block the area, if you block one area that is supposed to be responsible and it doesn't make a difference for performance, then the importance of that area can be reduced. On the other hand, if an area matters, it's not because that area per se, but it's because of course because the connections of that area with other ones. So as you heard from my story, there's nothing much to be gained in understanding by localizing an area that does something different. Now, so to summarize at one point, to summarize a little bit so far before I get to conscious and non-conscious studies, is there is when you talk about, and that probably counts for, I'm not talking about affective stimuli, but you can extend that affective stimuli to aesthetic stimuli. You can extend that to social stimuli, to cultural stimuli, etc. And I will have to give some examples. So the basic question is, if we start to think how the brain works and to rethink the brain, is do we first represent the visual categories in the mainstream view? Namely, we first say it's a face, it's a body, it's a voice, it's a scene, and then we look at how that is modulated by the affective valence, by the aesthetic valence, by the cultural valence, etc. Or is there a different approach? Namely, we rapidly decode the affective cultural social valence before or in parallel with this typical overrepresented stream of thought in the literature, that it's all about that the brain is first about representing objects, and all the rest is modulation of the representative objects. So one input for our thinking on that has, of course, been the studies we did on affective perception without visual awareness. Some studies looked at the role of attention and used, skip this one, patients with neglect, and to summarize that, skip that. Let's use another, because I skipped the studies that are published. Let's use an unpublished one. This is a study where the goal was to find to what extent are bodily expressions processed without awareness. I should give you some evidence from patients with bilateral visual cortex damage that show that those patients can appropriately react to the body expressions, but we wanted to know because patients can you get just that much. People tend to be skeptical about single cases, etc., sometimes for very good reasons. So we tried to create to design an experiment that would show that in normal adults, neurologically intact adults, body expressions are perceived without any awareness, and this is sort of a nice experiment for that. We did it with faces and with bodies. It works actually. It's been published with faces in Science, but it works much better and faster with bodies. So here the task is very simple. You get this mask, and then you get 3 dots you have a screen with a mask, like the left screen with a mask, 3 dots underneath it, and then there's a stimulus hidden in the middle screen, okay, which in our case is actually a body, as you see down here, with 16 milliseconds, and your task is simply to name the color change. Okay? So you never see the middle stimulus, because it's 16 milliseconds. You see the left and the right mask. The left mask changes color, here it becomes green. And then your task is simply to saccade, to make an eye movement to the color that is shown. Okay, so here it's red, up there it's green. But you have, it could be blue, green, or red. When that green color comes on, which actually hides the body here, you simply have to saccade to the color. So no mention of emotions, no mention of anything that's hidden between, that's squeezed in between the 2 masks. You have black, and the black becomes blue, green, or red, and you saccade to the green color. So what do we find there is that, and what the measure we take is the latency of this of course requires eye movement recordings. So the measure we take for non-conscious perception of body expressions is the latency to saccade to the color. So what we find there is that very clearly, not only is there evidence for people having unconsciously seen the angry or the body expression, but interestingly, maybe for some of you, we find also an important individual difference, namely, if on a separate questionnaire you turn out you're a dominant personality, then you're going to take more time to saccade from the unseen angry body expression to the color underneath. So that varies with the kind of personality. That varies with that personality variable. So on a simple task, remember, simple task saccading from central, when the color changes to one of the colors, which is the color you see. So that shows evidence for this non-conscious processing of the body expressions, and it also varies with personality. I had another experiment here which I can resist mentioning. You will see later on in this talk that we have done a lot of work with black bodies, bodies from black people, which is some work I have going on in South Africa. And in one experiment we were hiding black bodies versus white bodies, unseen in the same paradigm, and we do see that there is a difference in in the latency to saccade to the color for black versus white bodies. Let's do a tiny little bit of visual cortex damage patients. This is just one of them. So when you have a rare loss of visual cortex unilaterally or bilaterally, then you just are clinically blind in the sense that you have not on questions, do you see something, when the experiment is properly set up, then you reply, no, I don't see anything. Okay? So these are of course experiments that allow us to test non-conscious perception of face and body expressions, as we did, and I'm only showing one patient, but we have three of those obviously. So here what you do then is present the stimulus in the blind or in the intact field, and measure. In this case, what we did is no verbal report of anything, but measuring EMG, so measuring the change in potential at the muscle with simple electrodes there, as a function of what the person was shown, left or right. So this is actually EMG, that's a different one. So what we do here is first we show the stimulus in this case in the intact field, and we measure the electrodes simply measure what your reaction measured at that field. We also have pupillometry that's implanted. And we see that, of course, as expected, like in normal subjects, there will be a slight change in the electrical potential of the muscle here, when you see a facial expression that is like angry, or in this case fearful. So that's normal, you see there. It's the same for whether you see a face or a body. That's important because this stuff has been used by neural people as evidence for emotional contagion. But it can't be. It's really a reaction to the emotion, because you get exactly the same whether the stimulus is a face or a body. It's really. But when you show this to the blind field, you get very much the same pattern. both for faces and for bodies, with this difference, which you may have noticed already, that those arrows should be, those arrows doesn't matter, the arrows actually point to the point, draw your attention to the fact that you're substantially faster, that the muscular activity in your face is reaches peak substantially faster when you do not consciously see the stimulus than when you do see the stimulus consciously. Of course, there's two things to be said. You say, well, it's trivial because consciousness takes more time. Fine, sure. Okay. And that's okay. But the positive thing, of course, is that you actually do react to those unseen faces and bodies in your life. We actually have done this experiment combined with voices, but
just a question of fact, when did you try with neutral faces? Is it specific to emotional faces that you get feedback or whatever?
We could have added, as we have done in studies with schizophrenics and with autistics, we could have added neutral faces. But you have to make choices because it's, you already need for, these are like very subtle signals. It's not like a bang signal like you see it. You need very many presentations, consistency over very many presentations. So you try to choose the experimental conditions where that are critical. Okay, so this gets us a little bit closer to what I was saying about the brain. Rethinking the brain on the one hand is the well-known, the most familiar representation system, which is actually associated loosely with ventral stream functions, the functions in the brain whose job it is to tell you what it is, versus other areas of the brain that are at the service of appropriate, adaptive, useful reaction to what it is you see. And that does not require, in many cases, full identification of the stimulus in the ventral stream. So that's, and so not to be a little bit adventurous here, I would say that the dorsal dorsal stream system, including subcortical areas, is at the service of your being present in the event and reacting to the meaning of the event, while your ventral object recognition system is really at the service of sitting there and knowing and deciding what the things are, etc. And attention plays very differently in both systems. Okay, let's now go to some beginning of multisensory stuff. So I've given you my take on what perceiving bodies is, and that there's two systems for that, and a lot of it does not require any attention or consciousness. Now you know Dennis' famous statement about brains in a vat. No brains are embodied, but bodies are also not bodies in a vat. And so far, I've shown you experiments where you actually have used, let's say, I would almost say disembodied bodies, like body stimuli or body of video clips, with not much else around. And that's of course not what the brain is not made for dealing with bodies in isolation, like we complain when the sound is not working, because the normal experience involves it. So in bunch of studies now, I will give you some samples of work that looks at how we process bodies when they are, as is normally the case, combined with a facial expression, with a voice, or with a sound. So that's, I'm just going to give samples about those different things. And again, of course, the crucial question here is, when now we look at how the brain processes bodies, but in the context of a face, a voice, or a scene, where does that context, because in a way you can talk about multisensory influence as, I think Barry mentioned the term today yesterday, as an issue of cross-modal impact, which is one version of multisensory integration, cross-modal. But you can also, of course, have within modality, cross-category influences. So face to voice and face to scene are examples of cross-category, and those also exist, of course. It's also so. Let's quickly look at some experiments of bodies and faces, which were sort of fun to do at the time. What we did was glue Ekman faces on body expressions in a matching or in a mismatching. In a matching or in a mismatching. When you see it's pretty much the same facial expression with different kinds of bodies. We did that. Yeah, it's funny. Sort of in the beginning, it's very funny because this processing really goes in two stages. If you're like a Wundian trained introspectionist, your first flash, you say, here is something fishy here, and then you start looking. You say, But so this first impression is very strong, and indeed we used those first in an EEG study, and we did find that within 100 milliseconds there was a marker in the brain of incongruence. It was not specific in motion recognition, but there was a P100 was a marker of incongruence when subjects saw those stimuli for a very brief period. And indeed, as you see, this is in full view, of course. You see that their accuracy goes radically down. This is very, very similar, actually, what got me to this kind of experiment was, of course, all the experiments we had done in visual face expressions. The methodology is very, very similar. You just combine two sources of information, and you ask the subject, pay attention to that, ignore the other one, like you do in all the visual emotion studies, and you get this kind of very compelling effect, this very compelling bias effect. I do have some stuff for people who are interested in the amygdala. There's some interesting work going on because I'll just give you a hint of this. The amygdala, actually, we talk about the amygdala as like it's hard to publish a study in using fMRI in effective science when you don't have amygdala activation. It looks like the existence proof of doing something serious. People want amygdala. Otherwise, were the stimuli good, was this or that? But in fact, this is all very misleading because the amygdala consists of a whole bunch of subnuclei, and we don't really understand how they hang together, except that we do know for sure that their connections with the cortical areas varies very much depending on what nucleus of the amygdala you're talking about. So what we did actually is go to South Africa because there are Urbach-Bia patients there. And so far in the literature there's only one or two, and there's a bunch of them there with an interesting history, but that doesn't matter. It's a genetic disorder. It's a genetic degeneration, and it attacks specifically the nuclei of the amygdala. In a temporal progression, degeneration, a temporal progression, and we had patients where the amygdala, the basal nucleus of the amygdala was gone, and the rest was there. So I can tell you more about that. The anecdotically interesting aspect of this is that in all fMRI studies we always find maybe the word published otherwise, we always find amygdala activity for bodily expressions. However, there is a line of papers by Ralph Adolf who says that you only need the amygdala for faces, and even now in the most recent work you don't need the amygdala for faces anymore. But so we found that puzzling, so we gave body stimuli to these patients, and we do see that the amygdala is crucial for body emotion perception also. But it leads to actually hypervigilance rather than because the story in the textbook is no amygdala, no fear. But in fact, when you look at patients with specific subnuclei impairment, in this case, the basal nucleus down there, you see with hypervigilance rather than loss of focus. So that's just the amygdala story. Oops. Let's go and get body and scene. Obviously, given this meeting, I'm going to spend more time on bodies and voices to end the story. But bodies, of course, bodies are usually seen, usually perceived, let's say, metaphorically on the scene of the crime, right? Like bodies are seen, it's more likely that you see a fear body on the scene of an explosion and a happy body on the scene of an auto walk or beach area, etc. So we wanted to look at how the naturalistic surrounding context affects the perception of the emotion in the body, because that's also a very straightforward question. This is one of the fMRI studies where we did that. What is interesting of this one, and I'm just going to mention this, is that I've now by now conveyed my skepticism about body, face areas, etc. But we did find the strongest body area activity for the fear scene without a body present. So what's happening is when in the context of this experiment, when the brain perceives a fear eliciting scene, it sort of projects onto, it activates body representation, even if no physical body is present. So it's sort of predictive coding of the brain at that level. We can look at social. We are playing with the social scenes, and they include, of course, sounds and vocalizations and things like that. But let's go to body and voice to round off. Because this is like really new work. We did this old study published in '99, and where we found that combining incongruent face vocalization fragments and faces elicited the mismatch negativity. We followed that up with a behavioral experiment with this very typical curve. This is a paper from 2000. Very typical curve where we had morphed faces combined with either. So what you see is facial expressions going from happy to sad. And they are in the middle of the S curve is where there's no voice. It's a very standard categorical perception curve. However, if the same stimuli are combined with either a happy voice or a sad voice, that's going to push the categorization one way to one direction or to the other. So that's standard stuff. As we said in the previous speakers, I've said the explanation of that is still very much up for grabs as far as I'm concerned. As far as future growth concerned, so that's all to be understood. There have been fMRI studies of this, but they have been focusing very much on the conventional paradigm, namely comparing your activation conditions for face only and face and voice only, and then looking at the summation of these effects. And that's one way of doing it, but it has to be more there. Just an interesting, since culture and social factors were mentioned, we did a study which is still going on, but part of it is published last year or 2 years ago of Japanese. I always refused to believe that cultural factors would influence cross-modal integration. To some extent I was wrong, because we do find cultural differences, but they are of a particular kind. And what we did find in Japan is that comparatively, in a comparative study, Dutch and Japanese stimuli, Dutch and Japanese subjects, that comparatively the Japanese paid more, the weighing of the voice was stronger for the Japanese than for the Westerners. So their judgments are more guided by the emotion in the voice than by the emotion in the face. Now, there are trivial and hopefully also less trivial explanations for that that need to be investigated. So this was the situation with the Japanese speakers. Other audiovisual and face and voice differences you can find depends, of course, on the clinical group. This is a study we did with people with autism that also needs to be understood properly, just as we did a bunch of studies with schizophrenics on audiovisual representation. Getting to bodies and voices now, this is a masking study. As I said, we're very interested in perception of effective information that bypasses ongoing attention and consciousness. This was a study that used to go global with mask representation, and where we do find that, where we show, similar to that other study I showed, that fear bodies get detected, but get correctly detected even in a separate item by item confidence rating. The subject says he has very low confidence. So accuracy and confidence in judgment, this is important for consciousness discussions and awareness issues. Your answer and your confidence in your answer are two separate variables and can be manipulated separately. Now, in this same study, what we did next is not only show those masked bodies, but combine them with emotional voices. So you had the fixation, then a very brief flashing of body with backward masking, but that body was accompanied with a spoken sentence, and the subject's task was to rate the emotion in voice. They were never told that there were bodies living there. And you do see that the non-perceived body expression squeezed between the masks here influences how they consciously rate the emotion in voice. So we actually had shown that with totally blind patients also with the treatment of the states of the organs. Okay, let's now go to almost the end of my story. We've been frustrated for a long time that you can do those nice psychophysics experiments with morphed faces. So when we took up again recently the issue of multisensory integration with body expressions, we were mourning the lack of morphed body expressions until we finally found somebody who did them for us. And now we have these morphed continua of body expressions, which are very useful because they do allow you to explore the psychophysical techniques, just what is going on here. You can be much more fine-grained than by just showing a single body expression. Like all the experiments about masked body presentations, masks squeezed between two bodies squeezed between two masks. We could do that in a more refined way, parametrical way, by using any of these stimuli along, for example, this continuum from happy to angry, or the male continuum from happy to also from so that's work that's in progress. The first stages of physics is rounded off, and what you get here, we have plotted separately male and female those body morphs. We have the body morphs who knew they were working well, and we combined them with either a pure tone, that's the middle line that you don't see very well, the middle gray line, but you see when you combine them with angry as opposed to a happy voice, that you have very much the same pattern I showed you for all studies of face-voice combinations. You have your morphed faces, the classical morphed face study, then you do this with morphed bodies, combine it with voices, you get very much the same. You get very much the same pushing of your perception curve into the right or to the left as a function of the. I mean, this is sort of fine-grained psychophysics work. It's not like earth-shattering, but it's certainly an essential building stone for us to do this kind of work. You do see that there is no main effect of gender here, but that there is, of course, a very strong, clear effect of how you perceive. Again, I mean, just for the sake of clarity, the bodies don't have face expressions, and the instructions are shown very briefly, and the instructions are always to ignore, in this case, to ignore the tone. So it's always, most often used cross-modal bias because they are methodologically fairly clean. Predictable pattern in the reaction times, of course, and then you're in the middle of the curve. The highest latencies. Now, to come to culture, and here it's issues and questions, because we do a bunch of things. We do a bunch of things with black bodies, so we did create a black body continuum, similarly to so black female expression, going from happy to angry. In steps, we could have made it 11 steps, it doesn't matter, 7 is enough. Here, black, happy to angry, male continuum, and again, we presented them in a typical CP paradigm in combination with the voices, and we get something different, and I haven't understood why, but you're welcome to explain this for me. We do find a much stronger effect of the black bodies than of the white bodies. We find a very strong effect, but the effect is much stronger. But people have to rate, in terms of recognition of the body stimuli, there is no difference. Okay? But the effect of the voice on the black body, in the black body continuum, is much higher than you see here. it's of course in a sense. So why is that? Is that a phenomenon similar to the Japanese face ignoring effect? I mean, that needs to be studied as we go. So I said the body is body perception, which we can view. I mean, that's what I said at the beginning. We can view it as the brain as representing, object representation. We can see the brain as presence. It has consequences for how, I think it has consequences for how we view what how the senses are individuated, or how we look upon the merging of the senses. I do think I can't tell you how, but I have the feeling that follow one's hunches in that respect. It makes a difference for how we conceptualize multisensory stuff. And we of course all know that there is a lot of multisensory integration going on in subcortical structures, which are relevant for this presence representation versus the cortical structures relevant for the representation. Just as a little cherry on this cake, I have one quote. So as a little cherry on this cake, and that's my end. The body, of course, figures, it has, as I said, the many senses of the body. The body, of course, figures in cultural representations, in social representations, also in cultural aesthetic representations. And I just wanted to treat you to this study that's going on, where we use bodies in paintings, and we played a couple of tricks. For the purposes of clean experimental design, we manipulate the paintings, and we have this version versus male. We have male, female, and then we have this version versus. So we have the arrows versus the non-arrows, as we have for the males the arrows versus the non-arrows. Okay, actually, this is sort of. I have a sadistic PhD student, and she collected all the arrows from the San Sebastian paintings and put them in female bodies. So we did an fMRI study with that, and this was concerned with representing the body in pain and pleasure, which is an ongoing project we have. And we first created some stimuli of bodies in pain, but it's not very easy. And bodies in pleasure gets you in somewhat different areas of research. So we said, well, what about using paintings for this? And so we use this one. And we find that I mean, this is like very first level of data analysis, but when you look at the bodies without the paintings, without the arrows, you get massive activation in middle prefrontal cortex for that. The pleasure of viewing the paintings. These are purposely chosen, very naive paintings. And you may not believe it, but it's very easy nowadays to find 20-year-olds that have never seen any of these paintings. It's surprising, but this. So we also find when you look in more detail. So this is pleasure looking at bodies without the arrows. We have differences between males and females, and here we get much more activation for the female independently of the arrow condition. We get amygdala, we get prefrontal cortex, we get a lot of visual areas, we get premotor cortex, etc. So this is work in progress, and I thank you very much for being with me from the office.
For this talk, we have time for questions that are application more general.
So, with the study where you have the isocades varying according to dominant versus non-dominant personalities, how did you go about measuring that question of personality?
Oh, those are questionnaires. I mean, unfortunately, we have to rely on the questionnaires, and we already there's a bunch of them. Well, of course, what we hope is that we can validate this kind of. See, there is a lot of riches in these kinds of experiments that can be turned into measuring tools for that kind of stuff that do not depend on the verbal thing. That's one point. So I've been working with people actually in the VR labs, because what they want is like a very quick, reliable way of assessing whether somebody is dominant or violent or not. And with a 5-minute experiment, once you've understood the experiment, you can narrow it down to like a 5-minute simple thing to do. On the other hand, I do not expect that there's going to be a one-to-one relation between what you find in the questionnaire and what you find in your experiment. And that's a continuous stream of thinking of this, that there's two systems and they will not match. The same for the racial stuff. Of course, by official declaration, nobody is racist. I mean, there's some exceptions, of course, depending where you go to. But we do find very strong racial effects for the unseen black bodies. Does that match? Does that match with people's responses on questionnaires? For some it does, for others it doesn't.
Patrick.
Okay, so thank you very much for your talk. It was very interesting, and you began by linking emotions to the dorsal stream in some sense and saying that there might be a propensity for action. That's very interesting. And then at the end, on one of your final slides, you had this quite ambitious phrase, to experience significance. And that made me wonder about this whole idea of the effort after meaning, which is always a elusive thing. So just trying to put those two thoughts together, if emotions are about experiencing significance, you're committing, I think, to the idea that the dorsal stream is not just a system for action, but a system which is already capable of carrying meaning or carrying significance. And that's rather different from a classic view of the dorsal stream as being low-level orienting. So should we accept that even orienting or even propensity for action is meaning?
Well, I mean, let me first comment. I agree that I'm using dorsal stream as a means of getting understood by the audience. Because, so you're absolutely right to say that I put things in the dorsal stream. For example, I put a lot of subcortical stuff in what I conveniently call dorsal stream. Because the traditional dorsal stream is post-reward, so that's. But well, you know, I've been as an ex-philosopher. I've been for quite some time. I was working in philosophy of action at one point, and what people call nowadays action would never be called action in philosophy of action, because people now call movements an action. And there's all this stuff about mirror neurons being action, and it's just not correct. You only have an action when you have a meaning that you can uniquely attribute, and two movements, let's say, can be exactly the same and embody a completely different action. I mean, that's just, one should really reserve the notion of action for that matter. Just one more comment on the experiencing meaning. I'm not talking reluctantly using that term. I'm not talking about like some inner event. I mean, to experience meaning is to go back when you come close with your fist at me. It's not like some Cartesian event inside.
So just to follow up on that, is it what you call reaction would be a propensity to action with meaning, or propensity for movement?
A propensity to action, to make an adaptive move, we would say, to make the appropriate move.
The slides just with the bodies in pain, you know, they went back by a little fast. So I was just wondering what would be, you know, you showed a bunch of fMRI things, and could you just summarize those results?
Well, they're very, very recent results. I mean, you're just putting them inside out, cutting them up and slicing them up, understanding them. The one question actually behind this was, would people who actually know about this penis and know that the San Sebastian is represented with arrows in the body, would they experience this differently from the people who have no cultural backgrounds? And I mean, there is something funny. And for us, seeing a body transfigured by arrows going all over them, if you see that in a museum and you don't experience pain, you say, wow, well done, etc., etc. That kind of thing. While for somebody from a different culture, what's going on here, right? I mean, when we see, for example, Amazonian Indians with really, really big defigurations of the body, like with earlobes hanging to their head. All reaction is painful, and for those people it's beautiful. So that study tries to get those issues. So pain and pleasure, but including the cultural representation.
So the woman with arrows in it, that is strictly controlled for...
The woman with arrows in it is controlled, aside from being the pleasure of my sadistic Chinese students, it's a control for the man that naturally have the arrows in it.
Is it follow-up?
Yeah, I mean, that's a very complicated study, right? Because San Sebastian is also a homoerotic painting. Yeah. So for
as is very clear when you take the arrows out, when you Photoshop the arrows out of those bodies, it's amazing.
So you've got to screen for gender biases, right? I would have thought that I don't know of any homo.
See, this is San Sebastian without the arrows.
Well, you see, he's got the body is also in a sort of pleasurable pose.
Yes.
Oh, go on, stick an arrow into me. I mean, it's not hard to interpret what's going on there, but I was wondering whether you actually do any sort of gender profiling or sexual preference before you do.
Yes, my question, coming from across discipline and not from philosophy myself, I am interested to hear of the studies that have been conducted, and I did want to ask actually, has there been a study where the patterns of behaviour have been able to predict a particular type of behaviour, and also what ethical consequences? Okay, so my question is, the studies that have been conducted, has there been a way proven that you can predict a particular type of reaction or behaviour?
Yeah.
And also, what ethical considerations have to be taken into place?
Well, first of all, we take the standard ethical considerations into account, of course. Do you have something specific in mind?
I do. I'm trying to see if a particular course of action can be predicted.
Yeah. Well, we, of course, when I talk about the predicting course of action, take the specific case this is lab work, right? So, but when I show you a video clip of an angry person coming at you, okay, and you're just laying in the scanner or being in psychophysics lab, and I say that I have activity that I read as meaning preparation for an adaptive reaction. That doesn't, of course, mean that I expect the subject to run away. I mean, we have premotor cortex activity, for example, and that's one of the signatures, or for me, that's one of the signatures of understanding the action.
Hi. So, when you were considering the question about which comes first, stimulus recognition or emotional reaction, you told us about a really interesting blindsight study that you did, and what you concluded from that was that full identification of the object in the ventral stream isn't required for the dorsal stream to show an emotional reaction. But I take it that in order for the dorsal stream to show some emotional reaction, it's got to sort of identify some features of the stimulus in order to classify it as angry or threatening or happy or so. So do you have a good sense of which features have to be identified in order for the emotional reaction to take place? And then are we really talking about, these things are always really going to go hand in hand. I mean, it's sure that full identification at the conscious level, where I can tell you the nature of the object, in case of body and a threatening pose. I mean, sure, there might be emotional reactions that can go on before we get to that stage, but there must be identification of features that goes on in order.
There has to be some stimulus. I wouldn't call it identification, because that's all. You can look at an identification as the end point of a full ventral stream processing, right? I mean, take a simple anecdotal example. When This is a very simplistic example. When somebody comes across the street and approaches you very, very fast with likely with a fist or whatever, you very often not worrying about his identity, but get out of the way. You don't require full identification.
But there's got to be
There's not
representation.
No, we do. There is of course
representation of somebody coming towards me.
We have done various studies where we did spatial filtering of the stimuli to look to what extent various visual systems are involved. So you can allow spatial frequency filtered stimuli. For example, for the blindsight patients, it's now that that you have to stay within the window of spatial frequency of the stimuli for them to be processed. Otherwise, it just not happens. So there is that property of the stimuli. We are running studies on control for luminance to see what is. Sure, there is, but we have to know just what are the properties that are going to trigger them. So that means you have to selectively manipulate the visual image. Audio, the same counts, of course, for auditory, for other senses. You have to know what are the windows within which a stimulus activates a certain process. What is the minimum needed? For example, we have done studies with using MEG with the emotional bodies, where we get like very rapid activation from visual to orbitofrontal, without, and then in parallel but lower fusiform activity, so that kind of stuff. So that's I agree. I mean, there has to be like some kind. The stimulus has to, as the old action philosophy people used to say, it is a stimulus under a description. I mean, it is a product that it has to have certain properties, and it's just ongoing research just to know what those are.
I guess, I mean, just to follow up on this is where maybe the multisensory aspect is quite relevant. I mean, when you think about the McGurk, and you can think, okay, there is a representation of what is articulated from the visual point of view, and then there is a representation of what is auditorily uttered, and then you sort of fuse these two representation and you have a Bayesian sort of optimal. Or you could think there is no actual representation independently of the visual and the auditory, and what you just have is identification of the bundle. So maybe what you could get would be a bit the same, that you have visual processing and then other things, but there is no way in which you could think of it a previous sort of representation of separate features.
But if I may, your comment raises an interesting empirical issue also. The representation, what you call that is needed for identification, may be actually different in a multisensory setup than in a unisensory one. Maybe different.
No?
Thanks for a very interesting talk. I wanted to ask about the subtlety of body expressions. When we look at facial expressions, we can identify quite a few more subtle emotions, like, say, proud, playful, flirtatious. How many such subtleties can we go for with the body? It seemed like the happy body you presented seems more specifically to be doing some sort of triumphal gesture rather than,
Yeah, absolutely. Now, two answers. First of all, I don't see why there would be less for bodies than for faces. Number one. Number two, we do have to. One reason why we put those bodies and as we did with faces actually in context is because you do have to have a taxonomy of context much more than a taxonomy of isolated expressions. Because, as you say, happy.
Okay, I have two last questions, Colin.
Just thinking about the way you started with being rather critical of a conventional approach of neuroscience, to think of the brain.
Sorry, on Saturday morning I took it.
Thinking of the brain as forming using the senses to form representations of the world, as opposed to the brain as being a kind of developing a presence in the world. Are those two things really incompatible? To have a presence in the world and to use your sense organs to help you develop that presence requires the recognition that your sense organs are separate from each other. You have eyes and ears and so on and skin. You're trying to use them to develop information to support that sense of presence. really, and I've talked, a lot of your talk was exactly about the conventional approach of how the brain develops representations of emotional recognition form.
I absolutely agree, and it's only when you start playing with non-attention, non-conscious, etc. things and multisense that you can get to that other dimension, which is not one or the other, of course, obviously not. And I very much think that they operate in parallel. Furthermore, I think that they interact with each other. So it's just like some surgical intervention to at least pay some attention to the system as like the visual root, the visual system. The cortical visual system is so dominant that unless you sort of block it, knock it out, or do something, you'll never see anything else. But I agree.
Next question.
I think my question just follows up Colin's. Maybe there isn't a clear answer, but if we're trying to rethink the brain, it seems to me that still we could all accept that there's these emotional higher order representation systems that formed a big part of your talk, and that there's these unisensory systems. But the multisensory are like vision, audition, primary sensory areas. But it seems to me that still the multisensory areas are still a bit of a no man's land. That we aren't. It is this diffuse stuff. And there was a little bit of finesse talking about dorsal ventral. But I mean, dorsal ventral. We're going to say both dorsal and ventral are both multisensory routes.
Sure.
So then it is still a no man's land for the multisensory aspects.
I mean, you know as well as I do the standard stuff on you have auditory and then visual, and you sum it and you look for markers of real summation integration. Well, sure, but you would really think that there has to be more to that story.
Yeah, I was just wondering whether there was anything in that dorsal ventral distinction that I missed.
No, I mean, as Patrick, I mean, it's like very much for me like a complete, just a handle on naming that. I don't want to oppose cortical and subcortical. I mean, that's also misleading. So. And on the other hand, I want to acknowledge that if you look at EEG studies that have looked at used facial expressions, you see that they systematically and always find earlier activations, like in the ERP 100 millisecond window for facial expressions, than for faces versus objects. That recognition that is after 100 seconds, and we find the same with MEG so somehow it may sound a little bit naive, and it certainly is primitive at this stage, but somehow there is this apprehension of, quoted the meaning, quoted the affective verbs, and I prefer meaning to affective verbs because that sounds so emotional, right? So that has to, that requires less or different identification power of the brain to proceed.
Next one, let's thanks to very social ritual.